All right, so just a quick review of some of the big ideas in rotational motion. First big one, if we're talking about the kinematics part of it, is we want to make sure that we talk about angular versus linear velocity. So remember that if I have two different objects that are spinning around, their angular velocity of A would be equal to the angular velocity of B, but the linear velocity, oh, I should actually label these of A and B. The linear velocity of A would be greater than the linear velocity of B because it's making a bigger circle in the same amount of time. Other than that big idea, for the most part, the other big thing that I want to review on rotational kinematics is that rotational and linear are basically the same. So anything involving things like motion graphs or kinematics or whatever, you can basically treat it as a linear problem when you're answering it and have no real impact on your ability to solve it. The only big thing that they tend to look at comparing rotational and linear is that first piece we reviewed of looking at rotational versus linear velocities. So then going on down in rotational motion, we need to remember that we have rotational kinetic energy, and that's equal to 1/2 I omega squared. And just be careful that if you do have a rotating object that's going down a slope or something that starts rotating, some of the energy is going into that rotation instead of other places it could go, usually leading to it moving less slower in linear terms because it can't turn it into pure linear kinetic energy. It's sharing it between those two things. Um, remember how rotational inertia works. Rotational inertia basically is the idea that if we have mass far from our center of rotation, we're going to end up having more rotational inertia. The last piece that we need to talk about just comes down to a conservation of angular momentum. We want to have the angular momentum should be zero as long as there's no outside torques. And that comes back to the idea that if rotational inertia increases, angular velocity will decrease and vice versa. And if we are having changes in angular momentum, that's coming from a torque that's being applied over a period of time. So those are all of the ideas. When we put them all on this one page, hopefully it doesn't look like it's super intimidating. If you kind of seize onto these big facts and write that down on a piece of paper and then refer to them as you get to rotational motion questions, they should get you through the majority of the questions. So hopefully this just quick review helps you focus on the key ideas, and then remember to keep practicing. Make sure you do all of the paradox and things like that to make sure that you're solid on the concepts in individual situations instead of just kind of this like broad overview. So thanks for watching. That was it.